All right, so last week we talked about these new angle relationships. So corresponding angles. Angles that, like, when you give the description of them, left, right, above, below, they give the same description. Anybody want to try this first one? Give me the pairs of corresponding angles. Let's start with, like, what's corresponding to angle 1? If I were to describe angle 1, I would say it's to the left of that, like, diagonal line and above line A. So what other angle is on the left-hand side of a line and above line A?
4.
4 is below a line.
6.
6 is on the right, 5 is on the left. So 5 would be on the left of line T, which is up and down, and above that horizontal line. So it would be angle 1 and angle 5. What would go with angle 4? So angle 4 is on the left-hand side of the diagonal line and below line A. So I'm looking for another left below angle. 8. And then just to continue on, we could also do 2 and 6. And 3 and 7. All right, so all of those relationships are called corresponding. Same side interior means they're on the same side of the transversal. The transversal is the line that's intersecting the two lines. So this is the transversal because that's the only line in this picture that's intersecting two lines. So these angles need to be on the same side of that line. So either both on the top or both on the bottom. And they need to be on the inside. So remember, inside is like you can't get out, like there's walls around it. So my inside angles are 2, 5, 3, and 8, right? Because they're being blocked in by these lines. So what would be same side interior with 2? You can just call it out.
5.
Yep, and 5. And then we'd also have on the other side of the line 3 and 8. Right, those are my same side interior. Alternate interior, we're still looking at 2, 5, 3, and 8, but I need these to be on opposite sides of the line. And then the other piece of information you have to remember about alternate interior angles is they are non-adjacent. Does anybody remember what that means? Non-adjacent. They can't be next to each other, so I can't pick 2 and 5. I can't pick 2 and 3, right? Both of those are next to each other, so it must be 2 and 8. Okay, and then 3 and 5. And then the last relationship here would be alternate exterior angles. So these need to be on different sides of that purple line, but on the outside. So we're talking about the outside angles now. We're no longer talking about 2, 5, 3, and 8. We're talking about 1, 4, 6, and 7. So what would go with 1? Alternate, so it's got to be either 4 or 7, right? That's the other side of the line.
7.
And it can't be 4 because 4 is next to it. So 1 and 7 and 4 and 6. All right, down here they gave you the angles and then they want you to say what the relationship is. So 2 and 7 are these red angles. What would you call them?
Alternate exterior.
These are alternate exterior angles. All right, let's look at 8 and, or we'll go here, 5 and 4. What are those called?
Same side interior.
Yep, same side interior. Whoops, that's not right. Same side interior angles. Okay, let's see. 8 and 3. I think that's a hard relationship to see. But 3's on the inside and 8's on the outside. So it can't be something with the word inside and it can't be something with the word outside. So what other word do we have? Corresponding. These are corresponding angles. 6 and 4 These are on different sides of the transversal, right? That's the transversal, the line that's intersecting two lines, and these are on alternate sides. So these are alternate interior angles. And then finally, 1 and 5 is another pair of corresponding angles. So quick refresher on those, because what we're gonna do with those today is we're gonna add angle relationships. So like, see on the back how we wrote our equations, angle 1 plus angle 2 equals 180, and so on. We'll add rules to these. So then these pictures will be on the back too, just adding more rules. It will be the same rules, okay? Angle 1 plus angle 2 equals 180, and angle 1 equals angle 2. There will be no complementary. But the linear pair and the vertical rules will apply to these too, okay? So you're not memorizing new formulas, okay? You're just putting them to new words. So today we are going to identify relationships between these type of angles. We're going to do that in our toolkit. And then you can see eventually we'll be back in our workbook. So you're going to keep both of those out. So this is on your toolkit, page 8. We're almost done all this vocabulary. Now these aren't new definitions, but they're new formula. So you've got like this vocabulary chart on your paper. Today we're going to talk about parallel lines. You already know what parallel lines mean, right? There's two lines that never intersect. But just like you can't assume that something's a 90-degree angle without a box, you can't assume lines are parallel if they look parallel. You have to see a symbol. There are two different types of symbols that you might see. So the first symbol for parallel lines, let me see what you have. Okay, so the first symbol for parallel lines looks like this. So on the picture over here, this means that line L is parallel to line M. This symbol in the middle that almost looks like an 11 is the symbol for lines being parallel. The other symbol for parallel, and you can just circle it on your picture, is this. We know that the double arrow, an arrow on either side, means that it's a line, but this has a double arrow. Okay, so the black part of my image is telling me that this is a line. The red with the black is telling me these lines are parallel. So you can see they both have that symbol. That's showing that they're never going to touch. So that's another way to show that things are parallel. That double arrow, or you're going to see it in the symbol form. It almost looks like an 11. It's saying like parallel lines. So what we're going to learn today is if lines are parallel, then all of these relationships are true. So like we're going to learn different relationships between each of the parts. And then we'll start to actually put numbers to them. Okay, so if lines are parallel, then corresponding angles are always going to be congruent. Congruent means equal, okay? So in this image, it says general equation in this part. We're going to write angle A is equal to angle B. Now I'm calling it angle A and B because that picture has numbers. So I don't want to do 1 and 2 because you're going to think I'm talking about that 1 and 2, and I'm not. So I'm just going to use A and B instead of 1 and 2. But when I go to put it on the backboard, I'll make sure I use 1 and 2 to be consistent, okay? So if lines are parallel, then corresponding angles are equal, okay? But you have to have the symbol for parallel to be able to make that conjecture. So I've got two symbols for parallel here. I've got this double arrow like we talked about, and I've got this double line like we talked about, and the double arrow. So it's saying these lines are parallel. So my example says, okay, if angle 2 is 30 degrees, then what's the measure of its corresponding angle? So angle 2 is 30 degrees. So what I'm going to do is figure out what angle is corresponding to angle 2. And then I know that that's also 30 degrees. Because if lines are parallel, then corresponding angles are equal. So let's figure out what's corresponding to angle 2. Angle 2 is to the right of the transversal line and above the horizontal line. So what other angle is to the right of the transversal and above? 6. So angle 2 is equal to angle 6. I should put that over here. Angle 2 is equal to angle 6. So if angle 2 is 30 degrees, then angle 6 is 30 degrees. So angle 2 is 30 degrees, that's given to me. If these angles are equal, then that would mean that angle 6 is also 30 degrees. Corresponding angles are equal when lines are parallel. If lines aren't parallel, that's not true. Okay, so you have to have that symbol for parallel. So here we go. We've got the symbol for parallel again. So what's true about alternate interior angles? Alternate interior angles are also congruent. So angle A is equal to angle B again. And hopefully you can kind of see that, and I'll show you in the picture here. So if angle 5 is 110 degrees, what angle is alternate interior to angle 5? They need to be on alternate sides of the transversal, interior, and non-adjacent, because they can't be next to. 3. Look at angle 5. Would you agree that angle 5 is an obtuse angle? It's pretty big. And then look at angle 3, another obtuse. So even if you forget the relationship, you can kind of look at the picture and figure out if they're equal by seeing like, okay, they're both obtuse. They look about the same measure, okay? So if angle 5 is 110 degrees, because I'm given that, then angle 3 is also 110 degrees. Because alternate interior angles are congruent. We okay so far? These relationships only work if you've got this symbol though. Okay, if this symbol is not there, we cannot assume any of these things. All right, so same side interior angles. Angle A plus angle B equals 180. Here's how I remember this. Same side is supplementary. It's all your S's. Same side is supplementary. Same side equals 180 is supplementary. So those two angles will form a 180 degree angle. So if I have angle 6, then I just need to figure out what is the same side interior angle to angle 6, and that's angle 3. And you can tell they're not equal, right? Because angle 3 looks obtuse, but angle 6 looks acute, right? So just by looking at them alone, I can kind of assume they're not equal. And the only other relationship you're going to do is 180. So if they don't look equal, then they're 180, okay? So angle 6 plus angle 3 equals 180. So if angle 6 is 50, then we can solve for angle 3. Angle 3 must equal 130. Because together they have to add up to 180. Obviously you don't need to do the work to show that angle. If you can just say it, that's fine. So out of these three relationships, corresponding and alternate interior create equal angles. Same side interior, same side creates supplementary angles. They equal 180. And you can assume alternate exterior and same side exterior do the same relationship as interior ones do. Okay? So the next two, alternate exterior and same side exterior, follow the interior ones. So again, first we need to make sure they're equal or they're parallel. And once we know they're parallel, then alternate exterior angles are congruent. They're equal. So angle B is going to equal angle A. In this case, angle 2 and angle 8 are on alternate sides of the transversal and on the exterior. So angle 2 is going to be equal to angle 8 because they're an alternate exterior relationship. So this says that angle 2 is 8x plus 14. So I'm going to set that equal to angle 8 which is 15x minus 14. So subtract 8x. And I'm just going to also add 14 in the same line just because I don't have a lot of space. So if alternate exterior angles are equal, then equation 1 equals equation 2. I can solve for x. Now this one also says find the measure of angle 2. So I'm going to have to do 8 times 4 plus 14. So the measure of angle 2 is 46 degrees. So if angle 2 is 46 degrees, so is angle 8, and I don't even need to do any work because alternate exterior angles are equal. Everybody see what I did to get angle 2? I just took that equation and plugged x in. All right, our final relationship only works if lines are parallel and same side is supplementary. So angle A plus angle B equals 180. And this one's talking about angle 8 and angle 1. These are same side exterior angles. So angle 8 plus angle 1, because they're same side exterior, add together to equal 180. So I can take the equation for angle 8 and add it to the equation for angle 1 and set it equal to 180. And so all I'm doing here is just combining like terms. Someone want to tell me what this is? Anybody go ahead? And this one again says find the measure of angle 1. So I'm going to have to plug this into the angle 1 equation. So 20 times 5 plus 42. Angle 1 is 100 plus 42. Angle 1 is 142. Angle 8 is not 142. Remember, they are supplementary. So I am going to, if I wanted to find angle 8, which it doesn't say, I could either plug 5 into the equation, 6 times 5 plus 8, or I could do it this way. All right, we're going to get 38 either way. Right, those two angles add up to 180. So all of the relationships we learned, corresponding, alternate interior, alternate exterior, same side interior, same side exterior, they all have relationships that you can apply to them if lines are parallel. Like you need to see that symbol, right? All of the relationships are equal. Angle 1 equals angle 2, except for your same side. Same side is equal to supplementary angles 180. So you're going to try some practice with these. This practice is on Socrates, so you've got your room name, your class code there. See if you can apply the relationships to the examples on there. You can use your notes. I'm not asking you to have this memorized. I want to make sure I go over these because these results, you know, they're a little iffy. Make sure we're okay with this. So if you could close your laptops, put them away. I'm going to go over these ones that aren't in the 90s. So looking at this first one, it says if lines are parallel, then corresponding angles are. This was as simple as you picking up your toolkit and looking at your notes. Okay, so congruent. Okay, so you just have to look at that. It is only supplementary if it is same side interior, same side exterior. I would think that maybe because you heard me say same side supplementary, corresponding angles are on the same side, but the name doesn't say it, all right? So this only works if the name says it. Number 2, alternate exterior angles are congruent, okay? Anything alternate is congruent here. I think the next few were pretty good. Let's see, 95, all right, so 50. Here's my image. It says if angle 1 is 125 degrees, so this angle here is 125, what is the measure of angle 6? So the first thing you have to do is identify what their relationship is. Like here's your transversal, because that's the line that's intersecting 2 lines. Those are on the same side of the transversal, and they're also outside angles. They're not being blocked in by anything. So these are same side exterior angles. And same side is supplementary, meaning that these 2 angles add together to equal 180 degrees. So angle 1 plus angle 6 equals 180 degrees. So if angle 1 is 125, we can figure out what angle 6 is by subtracting the 125 from 180. So I was looking for angle 6 to be 55 here. These 2 angles together have to add up to be 180 degrees. So that was number 5. Angle 3 is 75 degrees. What's the measure of angle 7? Okay, these 2 angles are called corresponding angles. Angle 3 is on the bottom of the line, but it's to the left of the, or sorry, the right of the transversal. And angle 7 is the same. So angle 3 is equal to angle 7. The fact that they're in similar positions makes them have the same angle, okay? And you can kind of look at it. Are they both acute? Are they both obtuse? Or is one acute and one obtuse? So you can see the relationship from the picture. If they're both acute, then they're most likely equal. If they're both obtuse, then they're most likely equal. If one is acute and one is obtuse, then they're most likely supplementary, okay? Angle 3 and angle 7 look the same. It looks like I could pick up angle 3 and put it on top of angle 7 and they match. So they're equal, so I don't know where I wrote 4. Angle 7. So if I know that angle 3 is 75 degrees, well then angle 7 is also 75 degrees. Corresponding angles are congruent. This says that angle 6 is 80 degrees. What's the measure of angle 8? What's the relationship between angle 6 and angle 8?
Vertical.
Angle 6 and angle 8 are vertical. This has nothing to do with what we did today. We learned last week that vertical angles are equal. So angle 6 is equal to angle 8. So if angle 6 is 80 degrees, then angle 8 is also 80 degrees. Vertical angles are congruent. Okay, that relationship is on the back over. And then the last one gives me angle 4 is 20 degrees, and it's asking me about angle 3. Think about your pizza. If you eat angle 4 and angle 3, what's the relationship there? Supplementary, right? This is half of a pizza, if you look at it this way, and so this angle would have to be 180 minus 20. So this one's 160. All right. Hopefully that makes sense, because we're about to make it a little bit more tricky. In your toolkit, we're going to continue with this, but the examples are going to look harder. Remember at the end of the day on Friday when we did those more complicated pictures and we were pulling out the relationships? the pictures you're about to see are a little more complicated. So we're using the same rules, the picture's just a little harder. So on page 9, the first example here says, what are the measures of angle 3 and 4? How do you know? So here's what I'm given. I'm given one angle, and I'm given that that angle is 105 degrees. So the first thing I'm gonna do is, I'm gonna trace over this image to figure out which two lines make the angle that I'm given, all right? The angle I'm given is that 105. So this line here and this line here gives me the 105. And the 105 is on the left of this line and above this line, so it's right here. That's the angle I am given, so I'm just tracing the image to get just that angle. And then the first angle I want to solve for is angle 3, so I'm also going to trace over the lines that make angle 3. So angle 3 is this line and this line, so I'm going to draw one more line up here. And then angle 3 is on the right of this line and below, so it's here. So by picking apart that picture and writing down just what I want to know, and these are parallel because I see the image there with the arrow, what type of angles are 105 and angle 3? What are they called? The name, like alternate interior angles. Alternate interior angles are equal, right? So that means that angle 3 has to equal 105 degrees. So this is me picking apart this picture and taking only what I need to know. I'm going to do the same thing, but I'm going to do it for angle 4. So again, what made the angle I'm given? So I want to focus in only on what I know for sure, and I know that 105. So that 105 is on the left-hand side of this line and above, so it's here. And I also now want to solve for angle 4. So angle 4 is this line and this line. So now I'm going to add a line over here. Now in terms of this line, the angle 4 is on the right and above. So on the right and above puts angle 4 here. So by picking apart this picture, it's a little easier to see the relationship between those two angles. These are same side interior angles. And same side interior angles are supplementary. So angle 4 plus 105 equals 180. You can't solve this picture all at once. You have to pick it apart for the information you know and solve it one at a time. So looking at that big picture is going to look confusing. If you pick it apart, it is less confusing. So use what you know. Trace over what you know. All right? So over here it says find the value of x, then find the measure of the angle. Okay? So here's what I know. I need to find the measure of angle x, and there's two x's here. So I am going to trace over what makes this first x, and trace over what makes this second x. And I like to extend it a little bit because I think it's helpful to see it kind of the way we're used to. So if I were to redraw this image, this is x, and this is x minus 50. So if I need to solve for x, then I need to make sure that all of the x's are in my picture. So I'm tracing over the x's here. By doing that, I can see that these x's create this same side interior relationship, and a same side interior relationship is supplementary. Same side supplementary. So my angle x plus my angle x minus 50 add together to equal 180. And so this makes 2x. So now I've created this equation that I'm gonna be able to solve for x for. So x equals 115. And then it says find the measure of each angle. So if x equals 115, then this angle right here is 115. So what does this angle have to be if they're supplementary? What would the measure of that have to be? 65, right? Together they have to equal 180. Or you can just do 115 minus 50 to get the 65. So we have to identify what the relationship is first, right? And then apply that relationship to the example. I think there's one more in your toolkit. All right, so what I'm doing is I'm going to trace over the lines that make this angle here and this angle here, right? Because those are the two angles that I'm given. So what makes this angle is this line meeting this line. And what makes this relationship here is this line meeting this line. Nowhere in my picture did I use this line. So I'm going to redraw this picture without that left-hand line. So it looks like this. And I think it's helpful to just, like if that's the image that we have here, right? I think it's helpful to extend this line, and extend this line, just to make it more like the images you're used to seeing. Now, picking apart this picture, this 3x minus 10 is below the top line, but it's on the left-hand side, so it's this angle here. And this x plus 40 is below the bottom line and to the left of this diagonal line, so it's x plus 40. So now picking apart that picture, it makes it a little bit easier to see what that relationship is. Those angles are called corresponding angles. They're both below and to the left of the line. What do we know about corresponding angles? Corresponding angles are what?
Equal.
Congruent. They're equal. They're congruent. So they're the same, which means I can take the first angle and set it equal to the second angle. And I'm just doing the algebra kind of quick here because I think you'd be fine with that part. It's the setting up and knowing they're equal. And then it says, then find the measure of each labeled angle. Well, if x is 25, then this is 25 plus 40, which is 65. And if this is 65, then this is 65 too, because they're equal. You okay with that? All right, so the last thing that I'm going to have you do today is you're going to try something like that. So it's a little bit harder of a picture, and you're applying the rules. So take apart what you know, leave behind what you don't care about. This line didn't do anything for my picture, so it's unnecessary when I redraw it. Okay, so I'm picking it apart. Then apply those 5 angle rules. Corresponding alternate interior, alternate exterior are equal. Same side interior, same side exterior are supplementary. Okay? This is definitely not the page. Let me see, because I was wrong earlier. Let me see where I can find this picture. Anybody find it before me? Let me know. I'm seeing that one. I don't see it anywhere. Go to the back of your workbook. I don't know where it's at. Just copy this image down. It's pretty easy to copy down. So on the back of your workbook, just draw that image. Now I've got a hint for you. To solve for x, You need to only trace over the lines that make the x angles. Leave the y angles behind. Solve for x. To solve for y, trace over only the angles that make y and solve for y. You can't solve for x and y at the same time. You've got to solve for x separately, y separately.